Good morning, 8th graders. I just wanted to give you some notes about transformations. We've been going over this in math class, but there's a few tricks that might help you to be able to complete some of these problems a little more quickly, and it might just help make sense of it all. So let's review to begin with. We're going to talk about transformations. Now remember, transformations are made up of three different things. They are made up of rotations, which are spins, and they are made up of reflections, which are flips, and finally, they are made up of translations, which are slides. So, we need to be careful about not mixing up transformations and translations. Just remember that translations are a type of transformations. All right, let's look at each one of these a little more carefully. All right, we will start with rotations. Rotations happen at either 90 degrees, 180 degrees, or 270 degrees. Now, let me show you what that would look like. If you had a point here, and I was going to rotate it 90 degrees clockwise, remember, clock goes this way, right? Then that point is then going to end up somewhere down here. I'll put it in a different color so you can see better. If that same point was going to be rotated 180 degrees, it would end up somewhere over here. Because you see, from here to here is 90 degrees, because that's just one turn. From here to here, that's two turns, it's 180 degrees. So if we did 3 turns, it would end up all the way over here, and that's 1, 2, 3, and that's 270 degrees. Now, all I did to get the 180 and the 270 was take my original number of 90 and multiply it times 2 to get 180, and then times 3 to get 270. So you can see the way the point will move along the graph. Be mindful of clockwise versus counterclockwise. Remember, clockwise is this way, but counterclockwise would be going that way. There's our bell. So we have these different kinds of rotations, and we can use the grid and we can use tracing paper to figure out where they go, but we can also change the coordinates. So let me give you an example. I have points 4, 6, just pretending. If I was going to turn point 46 or rotate it 90 degrees, what I can do if I don't have graph paper in front of me, I don't have tracing paper in front of me, is I take my original numbers of 4 and 6 and I switch the order. And then the original y value, which is right here, you take the opposite of it. So usually you'd have xy, but when you do a 90-degree rotation, it becomes opposite y, x. So your numbers that you originally had don't change, but the order and the sign does change. That is the same thing for all 3 degrees. So if I have 4, 6 again, right here, and I want to rotate it 180 degrees, then I'm taking opposite x, opposite y. So my xy value, which were originally 4, 6, change, and I do the opposite of x, opposite y. Now I'm using the negative sign, but please be mindful that in this situation it really means the opposite. So if you already have a negative, it doesn't stay negative. You take the opposite, you change it to positive. So our new numbers here would be -4, -6. And remember, I'm using my original numbers, not these, not the ones I got here. So finally, 270 degrees, we have our x value of 4 and our y value of 6. But when we rotate 270 degrees, the order changes and we have y first and then opposite x. So that means 4, 6 becomes 6, -4. You will get used to this. It is a little hard. I don't want you to get stuck. I don't want you to get confused. I'm going to write this a little more neatly on the next page so that you can see it, okay? And now you can have this as a little bit of a notes page if you'd like. You're just moving those numbers around from the coordinate grid. You're changing from negative to positive or positive to negative. Just as a reminder, remember, negative sign means opposite. So if you have a -4 and you're taking the opposite, it becomes a 4. You do not leave the negative. Okay, let's talk about reflections. And I'm going to give you the way we can change the coordinate numbers for this without having to use graph paper, much like I just did for the rotations. So when we reflect over the x-axis or over the y-axis. Let me fix that. So when we reflect over the x-axis, we have our x, y value, and that becomes x opposite y. So don't get confused, because you'd think maybe when you're reflecting over the x-axis that the x value would change, but really the y value is what changes. So what do you think? When we reflect over the y-axis, what do you think is going to happen? Well, we are going to have opposite x, y. So the y value does not change, but you have to take the opposite of the x value. Finally, let's look at translations, which I honestly think are the easiest. Because all you're doing is sliding whichever way they tell you to slide. So if they say move up 1 and left 2, all you'd be doing is taking each point, going up 1, left, that's my right. Let's try that again. Going up 1, left 2, up 1, left 2 for each point. All you're doing with translations is exactly what they tell you to do on the paper. It can be harder to describe if you have to say, which way it went. If that's the question, which you will get asked, you're going to have to describe it. And you should describe it in terms of left and right and up and down. So you might have to look at your original image and see where the new image is and figure out the numbers in between. Okay, I hope that this helps. You should be able to do these problems without graphing paper or tracing paper now if need be. But I'm still here to help you if you need anything. So let me know. I hope you're all doing well. Bye.